Well, welcome everyone to today's webinar. My name is Paul Gannett, and I'm going to be your host for the webinar today. Really glad to have you with us. Today I'll be talking about the HOBO remote water level monitoring system and how it can be used for dam management. Oops, sorry. There we go. This is in case anybody's not able to hear me. Please check your audio settings, although you're not hearing me say that, but this just gives them a couple of prompts. Now we'll move on to, this is where the questions box is in your control panel. So this is where you can enter questions at any time during the webinar and also during the specific question and answer times. So look for that. The webinar, it's going to last about 40 minutes of presentation time, and that leaves us about 20 minutes for questions if we have that many questions. Really, it's up to how many questions we have. And we will be making the recording available to all of you after the webinar. So just a little bit about Onset for those of you who are not familiar with us. We make the HOBO data loggers, and some people sometimes ask, who makes the HOBO data loggers? And it's us. We are the manufacturer and the designer of the HOBO data loggers. This is our sole focus, is data logging and monitoring. We are celebrating our 40th year this year, so a very exciting year for us. So we've a lot of experience doing this. We're located on Cape Cod, Massachusetts, and we are ISO 9000 certified. For those of you who aren't familiar with that, it's basically an outside certification of the quality of our processes and documentation, and it helps ensure you get the quality products that you expect from us. So just in the way of a quick introduction to me, I'm the environmental product manager for Onset's HOBO line. I've been with Onset now for 24 years. So I've worked with engineering over that time to develop our lines of HOBO data loggers and stations for environmental applications, including the HOBO remote water level monitoring stations that I will be talking about today. And I do live and work here on Cape Cod, Massachusetts, where we're surrounded by the ocean and with streams and ponds, and we really value our environment here, and we really take great pride in making products that help protect our environment. So I'm going to turn off my webcam now. And we're going to go into a couple of poll questions. I've told you a little bit about us. I'd like to find out a little bit about you, just so I can better tailor my thoughts to what your needs are. And so my first question is going to be, and we'll enable the poll in a second. The first question is going to be, how many dams do you need to monitor? So here's a few different size ranges. And I know some of you are actually doing other applications. So what we ask there is just check this, the last choice and enter your application, just real briefly, a word or two about your application in the questions box. So that just gives me a sense for what you're doing. So let's turn on the poll. Okay, this is giving me a good sense. So I want a good mix of other applications. Yeah, interestingly, the majority of you, or not quite the majority, but the largest portion of you are doing other applications. And I see some river monitoring, hydrology, beaver dams, so interesting, or some runoff, wetlands, good range of applications, all involving water levels. So yeah, we'll have a lot to talk about that's relevant for you. And yeah, then the next biggest portion of you are doing 2 to 4 dams. So that's interesting. And then the next is just 1 dam. Okay, so a good mix. A few of you got some larger networks, and we'll be speaking to those as well. Okay, I see some questions. Good, good. So let's go to the next poll question, just to find out a little bit more. And I just wanted to get a sense for where you're at today in terms of what you're using to monitor dams. And this was a question where you can answer all that you're using: staff gauges, remote water level, doing a visual check, looking at where the water level is, and just other methods. And to be honest, I'm using this as an opportunity to learn a little bit about other methods you're using to monitor dams. So let's enable the poll. Interesting, very evenly split that I'm seeing here. So we'll share these results with you in a second, but interesting. Oh, and all of the above. Yeah, that makes sense. Okay, I think we got a good sense here. And so let's share the results. And there they are. Yeah, the biggest portion of you are using staff gauges, but it's pretty even, like I was saying, between using remote water level stations, kind of like we're talking about today, as well as visual checks. And then there's some other methods. Here's what are some of the other methods? Tape measure, yep, all of the above. A few people said all of the above. Yep, got some other good questions in there. So good. I'm glad to see some questions in. We'll take a pause at a couple points during the presentation to answer those questions. So let's close out of the polls. Thanks for sharing that information. It's good to know a little bit about you. This is just a quick overview of what we're going to be covering. First, I'm going to be talking a little bit about why dam management is so important. I think most of you realize that, otherwise you wouldn't have signed up and be attending. Then I'll talk about our remote water level monitoring station. We'll take a little break for some questions there. Then I'll go through a couple of examples of some dam monitoring applications, and then we'll wrap up with more questions and answers. That's it. So first off, why is dam management so important? Here's just a few things that kind of point to the importance of it. Looking on Wikipedia, you look at all the notable dam failures that they identified between 2000 and 2009. This is the one that jumped out at me, and damsafety.org, which is an organization that many of you may be part of. In 2019, there were approximately, or at that time, 15,000 high hazard dams in the United States. That surprised me. Now, that doesn't mean that they're on the brink of failure. That means that if there is a failure, it's a high risk. So that's based on the risk level. And here's one just from this past year, 2020. More than 10,000 people had to be evacuated after the Edenville and Sanford dams failed in Michigan. So that's some of the flooding that resulted from that. So clearly very important to be monitoring dams and protecting lives and property downstream of them, as well as other benefits. So how can a web-enabled system help? Well, probably those of you who are familiar with monitoring dams, you are either considering or already have emergency action plans, EAPs in place. So these can be an important part of those EAPs. Alarm notifications when the water levels get too high or too low. You want to know about those. Also, if there's high levels of rainfall, a remote monitoring system can notify you of those. It also allows you to easily view current conditions and trends. You can see if your water levels are rising rapidly, so you can kind of anticipate where things are headed. And another thing that's important is during a storm event, you've got to take action, especially if you're managing multiple dams. You need to know which ones are at the highest risk, and therefore the ones that you need to prioritize and address first. So having that information at your fingertips is critical. And for those of you who are dam managers, you need to keep yourself informed. A lot of times you also have to keep your stakeholders informed of what's happening. And if you're part of a larger monitoring network, you need to be able to integrate into that network. So let me talk a little bit about the HOBO Micro RX station. Just kind of going back here, I don't know if you noticed it. This is the HOBO Micro RX station mounted on a small dam in Australia. And this is a close-up view of it. So let me give you a quick tour of what it does. It's as you can see, it's very compact. It has an integrated solar panel, and it is completely solar powered, and it has rechargeable batteries inside it. The fact that it's all one unit like this and a pretty small unit makes it very easy to mount, and also makes it easy to conceal if necessary. You know, sometimes that's a concern. And this black area is the solar panel. It doesn't look very solar panel-ish, but it is in fact a solar panel. It does the job very well. It has integrated 4G cellular communications that is all built into the enclosure as well. It has real-time monitoring capability. Depending upon the data plan, you can either get hourly or 10-minute update rates. So that 10-minute update rate really allows you to keep a very close real-time view of what's going on. It includes integrated alarm notifications, and I'll talk more about those in a couple slides. And it has an integrated water level sensor. So it plugs in inside the station, and then you buy a cable of the appropriate length, and here's the sensor that gets mounted down in the water. It's a non-vented sensor, which gives you the best reliability and the lowest maintenance. You don't have to be changing out desiccants over time like you do with the vented sensors. And the station has built-in barometric measurement capability, so that's used to compensate for barometric pressure changes. So the station's able to provide water level data directly. In terms of pricing, I'm sorry, I just saw a message here that had me concerned, but no worries. Let me turn that message off so I don't get nervous. The pricing for a station is just over $1,000 for the station with a water level sensor and a cable. Of course, as you get longer cable lengths, the pricing is going to be a little bit higher than that. You can add a rain sensor to that station for basically $200. These are all US prices, of course. I know many of you are international. And the data plans for an hourly connection rate, those are $150 per year, and it's $250 per year for the 10-minute connection rate plan. And so those data plan costs include both the cellular service as well as the access through our HOBOlink software platform, which I'll talk about in a minute. So as you can see, for under $1,500, you can get a complete station and a year of service. So very, very reasonably priced. What's inside the station? So this is with the cover open. Let me give you a quick tour. It's got the integrated mounting ears. It makes it easy to mount with U-bolts or zip ties or screws. It's got an LCD display, which can help with initial system configuration and troubleshooting if you ever have any issues. You know, it shows things like signal strength and battery status, the number of channels that are currently being used. So that's pretty handy. This is the input for the water level sensor. You just plug that in, and there's a couple screws that you also use to secure it in place so that it can suspend the sensor in a well. It's got 5 smart sensor inputs, and these are for any of our Onset smart sensors for a range of weather parameters, including rain, wind, temperature, humidity, light. We'll talk a little bit more about those in a few slides. And it's got this waterproof gasket down here. This is where the sensor cables will come out, and it's a very robust weatherproof seal that goes around those cables. It's got a, you can buy it two ways. You can buy it with a SIM from us and a data plan from us, and the SIM gets installed there, or you can supply your own SIMs and basically manage your own data plans. There still is a service plan you need to subscribe to from us for the HOBOlink part of the service, but you can provide your own cellular service. And it also has a USB interface for basically emergency data offload. If you need to get the data for some reason, the cell network goes down and you need your data. And it does have two latches on it, which aren't really shown here, but this is the one side of the latches. And those do have holes in them that can accept user supplied padlocks. That is, sometimes these stations are in places where people could tamper with them, and it's handy to have that padlock just to secure it closed. It's obviously not a complete protection, but it's handy to prevent or protect it from the casual vandalism. The other key part of the system is our HOBOlink web software platform. This is your interface to the station through the internet. You use it for configuring the station. In particular, this is showing the screen for configuring the alarms. You can set up alarms with multiple email or text addresses for sending the alarm notifications, and you can set them up at different levels so that you can have different alarm notification lists for different degrees of alarm conditions. And here's a question I just came through. I am kind of out of the corner of my eye monitoring questions, and I just see somebody asked about how many sensors can be connected to one unit. And I'm just going to go back here real quick before I get too far beyond this. This has inputs for 5 smart sensor inputs. So just to answer that question, so coming back to the software, this is also where you can view the data. So this is the standard view of graphs of the current conditions. It'll show the trends for either the past day, the past week, or the past month. It's got cursor readouts so you can see what the conditions were at any point. This is showing the daily rainfall accumulations over time. This is showing the water level. Sorry, that line is in yellow, so it's a little hard to see. So this is all accessible through any web browser. So very easy to access. You have your own secure account, so you have your own password and login credentials, of course. You can, you're the only one that has access to your account, but you can, I'll talk about data sharing options for sharing the information with others. One of the other capabilities that's built into HOBOlink is the conversion of water level to water flow information. This can be useful for measuring inflows and outflows into your body of water that you're monitoring, as well as during overflow events. It could be monitoring the water flowing through a spillway, so you have a record of how much water was going through there during the storm event. And this just is pointing out where on the screen you set up the flow monitoring. It's designed to be used in conjunction with a weir or a flume or a stage discharge curve. So this is where you select which type of device you're using to monitor the flows. And you just select that there and then enter in the appropriate information for your weir or flume. Another feature of HOBOlink is you can set up custom dashboards which present just the information that you're interested in, or that your stakeholders are interested in. So here's one where it's showing the current water level, temperature, water level versus rainfall on the same graph, as well as air temperature. So it's very focused to just what's of interest. You can easily share these dashboards with others. Our HOBOlink will give you a link which you can share with other users by email. You can post that if you have a website where you're sharing information on your body of water. You can post a link to this dashboard on there, and you can have multiple dashboards. So you can share different dashboards with different users and in different places. And the dashboards are designed so that they will show, you can use them from a desktop browser, or you can use it on your mobile device, like a smartphone or an iPad, and it kind of rescales the data so that it's clear. So very flexible in terms of how you view the data with your dashboard. The alarms, there's different types of alarms, so I just wanted to talk about those. And obviously for dam applications, alarms are very critical. They can tell you if the water level is getting too high or too low. We also have accumulated rainfall alarms where you set the accumulation interval, be it every, a running total of the rainfall over the last hour or the last 4 hours, whatever interval you select, and you can set a threshold for that. If it's more than an inch over the last 2 hours, you can have it give you an alarm notification. And one of the things that's important about these alarms is these are calculated in the station. So let's say you only have a hourly connection plan. If an alarm condition happens partway through that hour, it'll cause the station to immediately connect to the HOBOlink and generate that alarm notification to you and your stakeholders, so you don't have to wait for the next scheduled connection. And I think I mentioned this briefly before, you can have either text or email notifications, and each alarm level can have its own notification list. And there's also something called system alarms, and this is important for things like, let's say you've got a sensor that failed. This will give you a notification that you had a sensor failure, so you can get out there and fix it before you get into a critical storm event. And it also notify you of things like if for some reason the internet goes down, or the site that's hosting HOBOlink goes down. We have an independent site that's monitoring that the site's still alive, looking for heartbeats, and it will give you a notification that for some reason the station is not communicating with HOBOlink, and that way you at least know that, hey, I need to get out there and check for the current conditions, because for some reason my system's not connecting to the internet. So that information is important as well. We also have integrated map views. You can set up multiple monitoring stations all in the same map, and just kind of the typical Google overlay like you're used to. And to see the details on a particular station, you just click on that particular station and it will tell you the current conditions at that station. And this is important more for you folks that are part of a larger network. You may be using some network management program that's accumulating data and information from several stations in an area. Some of these networks can be over 1,000 stations, some of the bigger ones. So DataWise and Aquarius are some programs that, or they're really more than, they're platforms, software platforms that help you manage these networks and the data that you get. So we have integration options for delivering data to both those types of networks, web services, automated data delivery. And we also maintain a historical record of the data in HOBOlink so that you can, if you want to go back a year ago to see what happened or what was happening, that data is all archived for you as part of HOBOlink. So so far I've been talking about the Hobo Micro RX station. We also have the Hobo RX 3000 remote monitoring station, which gives you a few more options and greater expandability. So let me talk a little bit about that. I've noticed in here that there's a few questions about what about areas with no cell coverage. So I see, I've seen a few questions coming through about that. So let me mention that this is an option for those. I should first mention that the cellular providers that we work through are it's 4G through AT&T and T-Mobile, and internationally there's several different providers we work through in each country. So we do list the providers that we work through in the different countries on our website. I forget exactly where that is, but that information is available, and you can always ask us for that. But if your site doesn't have coverage with one of those cellular providers that we support, we do have Wi-Fi and Ethernet options for the RX 3000. Now, Ethernet's probably not available, but sometimes you can set up a web connection with a Wi-Fi receiver, and you can use that as your way of getting data from some of these remote sites. Now, I know in some cases that won't work. We do not have a satellite option at this point. That's something that obviously we'd like to, add in the future, but we're not there yet. So I don't want to set any false expectations. So keep this Wi-Fi option in mind as a possibility if you can make that work. Other features about the RX 3000 is that it has 10 smart sensor inputs. So that's an additional 5 over the Micro RX. It also has slots for 2 modules. That's what we're showing this person installing here is a module. I think this might be, I don't even know which module that is, maybe a relay output module. This is an analog input module. And we have one for water level sensors. So if you want to connect in a water level sensor to it, you use one of these slots for that water level sensor. You can have 2 of those water level sensor modules in there. So if you want to monitor water level in 2 different spots at your site, you can do that very easily with the station. The analog input modules are useful for connecting third-party sensors. If there's some specialized parameter, such as pH or something that you want to monitor at the site, you can do that by connecting in a pH sensor that has a 4 to 20 milliamp output. Connect that to the analog module. We also have HOBOnet. Let me say that correctly. HOBOnet wireless sensors for environmental parameters. You can interface to those by plugging in a module that basically plugs in a receiver to HOBOnet wireless sensors. We also have one for relay control, so you can put in up to 2 modules. Another question we get is, let's say you're in a really remote site and you're not sure how much sun is going to get there. It is possible to use other power options. So you could, for example, have a external car battery, a 12-volt car battery with a super huge solar panel or some other method of recharging that car battery, and use that to power the RX 3000 station. So that's just another power option you have for those remote sites. I see there's a question on pricing. I'll address that on this slide here. So the stations with water level sensors, the RX 3000 stations, start at just over $1,500, and that price applies to whether you're getting the Wi-Fi, the Ethernet, or the cellular version. They're actually the stations are all the same price. The difference is in the data plans. The cellular station is going to need to have a data plan. So that's, it's the same data plans as for the Micro RX, starting at $150 per year. We do have some no-cost data plans available for the Ethernet and Wi-Fi options if you choose those. So that's something to keep in mind as well. The RX 3000 does need an external solar panel. We sell those in different sizes, 5 watt and 15 watt. So those are plenty of power for powering the station, as well as any sensors that are attached to it. And that solar panel, the basic 5 watt solar panel, I've included in this price here. So basically, difference in price between these stations and the Micro RX stations is about $500 US. So if you need the expandability that I was talking about, it's well worth that extra small extra price to pay to get this station. They both accept the same range of smart sensors. This is a different one of the range sensors that we offer. It's a nice rainfall sensor. It's actually made by Texas Electronics, and it's a very robust sensor, been proven over many years. So speaking of the additional sensors, here's some of the other sensors that are available, all your typical weather parameters, and as well as soil moisture, also water temperature, soil temperature if that's of interest. And as I mentioned before, the analog input module allows you to connect other sensors as well. So yeah, those are the two stations, the Micro RX, the RX 3000. The software, I should say, is the same for both of them. It's the same HOBOlink interface, and it's quite common for people to have a mix of Micro RX and RX 3000 stations in the same network, and they all work seamlessly together. So I see, Julie, you have a question here on the price for these sensors, so this is probably a good time to address that. We have two levels of rainfall sensors. The least expensive rainfall sensors are $199 US each, and then the higher end Texas Electronics rain gauge, we sell those. I think it's 420 US, somewhere in that neighborhood. So just a hair over $400 for those. Temperature sensors, those are about started around $100. Temperature RH around 150. Just gives you a sense. Wind sensors, I think those start at 200. So I don't have our prices memorized, but I just want to get you in the ballpark so you have an idea of what you're in for. Somebody just asked if we have a smart sensor, Hutch, if we have a smart sensor for salinity, and we do not have that. We have standalone salinity loggers, but we don't have a sensor for that will plug into our stations. But we do, we work with a company called pH Ionics, and they make a salinity sensor and a conductivity sensor that has a 4 to 20 milliamp output, and we have a lot of users that are interfacing their sensors into our RX 3000 stations with an analog input module. So somebody else is good questions, so keep them coming. Turbidity sensors, to be honest, those are a little harder to come by. The one that I'm aware of that has an analog output, I can't remember the name. Well, who is that makes that? Oh, it's Global Water, which sells that turbidity sensor with an analog output. So you can check out their turbidity sensor and consider interfacing it to our station. So yeah, happy to. And as you have other sensors you want to connect up, feel free to give us a call, and we'll if we know of them, we'll be happy to refer you to sensors that we know other users have used. Here's another good question. Rebecca was asking, can one of your units bounce its data to another, like a mesh network? These stations each have their own cellular connections. But if you go back to let's see if I can, how far back I have to go? Yeah, a couple slides. I mentioned this HOBOnet wireless receiver. Those are wireless sensors that do connect in a mesh configuration. So for the environmental parameters, you can have up to 50 wireless sensors talking into one station. But we don't, to be honest, we don't have a water level sensor for that at this point, but we do have a range of environmental sensors, basically the same range of environmental sensors you can get in wireless forms, and connect them into one of our stations as well. So good questions. So yeah, and just to confirm, Julie, you're asking, so this unit could function as a weather station and a water level station at the same time, and yes, absolutely. These stations are very much designed to be measuring both water level and weather parameters at the same time. So the micro station will handle one water level sensor and 5 other smart sensors for the other environmental parameters, and the RX3000 will handle up to 2 water level sensors and up to 10 other sensors coming into it. So yeah, a lot of flexibility to adapt to your application. Another handy accessory for deploying these is a well cap that has a pass-through for the sensor cable to go through it. And so we've designed a special little mounting accessory that allows the cable to pass through, as well as having an opening if you need to run a water level meter to record current water level to get calibration readings at some point. It's got that opening for that. And this just is a nice convenient way of suspending the water level sensor in a well. So this is designed for a 2-inch well. So if you have other diameter wells, you might need an adapter, obviously, to use this. Or, a lot of users will fashion their own well caps too to adapt to their particular well. So I'm going to take a break here. We're at 40 minutes, and just to answer a few of the questions. And I do apologize. I've gotten enough. I may not be able to get to all the questions, so I'll just address some of them, and we can always, any questions I don't get to today, we'll follow up with you. So not to worry. There's a question about the transducers for the RX3000 needing to be vented or not. So this comes from Phil. The RX3000 sensors is basically the same as the ones in the micro RX water level station. So they're exactly the same sensors. So they're non-vented sensors, and they use basically the same cables, to get the data up to the service. It has a slightly different connector at the top, and I mentioned that for the RX3000, you would buy a water level sensor module that plugs into the RX3000. Well, that module has the barometric sensor built into it. So that'll provide your barometric pressure data for doing the compensation. So you can get the water level directly with the RX3000 the same way you can get it directly with the the micro RX. So hopefully that answers that. Let's look at what else. Thanks. I think we've covered most of these. Sorry, I'm having to pause here. Just there's a question about Bluetooth connectivity to our stations. These stations have a USB interface to them, so you have to plug in a USB cable to offload the data if you need to do that. Most of the time, you're accessing the data through the internet, through the HOBOlink interface. So that's your primary method for communicating with these stations. Yeah, here's a good question from Richard. Is protection methods for wire between sensor and RX unit during winter conditions when water in a standpipe freezes? Yeah, that's a challenge. You do want to put the cables in some sort of stilling well to protect the cables as much as possible. The cables do have a Kevlar strength member in the cable, which gives them a fair amount of strength, but ice is tough. So that's why if you have a stilling well around the cable, that minimizes the amount of ice that's directly in contact with the cable, and in most cases it'll be okay. But yeah, if you do have applications where your cables are going to get frozen in the ice, you definitely want to keep an eye on them just in case there's an issue with it. So you can get out there and replace the cable if necessary. So, good question. So what I'm going to do is, okay, we're just in the spirit of time, I think I've gotten through most of them. I apologize again if I've missed some of yours, and maybe we'll have a little time to get back to them. But I want to go through a couple of example applications because I think these will be real useful for you as well. So let me go to those. So just in terms of typical applications, we find that the applications largely fall into two types. One is like homeowner associations, which have one or 2 points that they need to monitor their dam at. So usually, a smaller organization, you guys may or may not have, you probably don't have an IT department. You just, you got some volunteers or some board members that are managing your dam and need to keep a close eye on it. So we have a lot of users that are like you that are doing that, and I'll talk about some of the advantages of the station specifically for these smaller 1 or 2 station networks. And then we have some users that are part of larger monitoring networks, and your challenges are a little different because you've got to worry about managing all the data and information. So let me talk first about the smaller homeowner association type applications. You guys will like the fact that it's easy to set up our stations. The MicroRx especially is all integrated into one unit. It's easy software configuration. You don't need an IT department to set this stuff up. You have your own secure account. You can set up your own dashboards that you can view yourself and share with the association members as appropriate. And I'm going to show an example in a couple slides that specifically of a homeowner association application. I think you'll find that interesting. For larger networks, again, it's nice that our stations are easy to install and set up. They're exceptionally durable. We have users in all sorts of extreme environments, from the hottest deserts to the coldest Arctic conditions, that are using our stations, and they've proven to be very reliable in all of these applications. The other benefit for some of the larger networks is the easy integration with programs like DataWise and Aquarius. So now I'm going to go into a couple of specific examples. So the first one I'm going to talk about is the Falcon Bridge Neighborhood Pond. It's a neighborhood association. These guys are down in North Carolina. And here's a couple of views of their situation. So they've got this earthen dam here on this one side. They've got houses that are kind of downstream of that dam. And you can see the side view of the dam here in this picture on the right. And you can see, it's not super large, but it's certainly important to keep the pond level maintained and protect the houses and people downstream. Back in 2017 and 18, there were some large storm events that resulted in overtopping of the dam. As you can see, this is an actual picture, and you can see of the dam overtopping. You can see the water running over and into the area downstream. This was during Hurricane Florence in 2018. They did inspections, after these storm events, and there was no critical deficiencies, but the dam's classification was changed to high hazard at that point, which required the implementation of an emergency action plan with the goals of preventing overtopping and protecting nearby residential areas. So this is the system that they came up with. Bigger drain device in the dam here. Now I'm going to go to, this is another view of the AgriDam device. So if it does start to overtop the dam, it's got a drain there, and it'll collect some of the water as it's overtopping into the device. And here's the plates that get added or removed to help control the pond level. I'll just give you a little sense for that. Some of you may be using those. And here's the micro RX station installation that they did. So this provides them the current water level and rainfall data. So you can see the rainfall sensor here, as well as their stilling well with our cap on top, with the water level sensor down in the stilling well. This is just a ordinary 2-inch PVC pipe with holes drilled into it to allow the water to get in there. And they can view the current conditions anytime with through HOBOlink and a standard web browser. This is now part of their emergency action plan. It gives them a complete record of what's been happening over time. And again, no programming required. And one of the things that they did is they mounted it on this board that can be easily removed from the mounting post, so that if they need to service the pond or they need to service the station, they can remove this and easily do the servicing that they need. Thought that was a good idea. Here's another picture of their pond and the station in the pond. Looks like a beautiful, beautiful pond. And here's some of the data they collected. So in this analysis, what they were looking at is the pond level, which was the orange line. And you can see the scale for their pond level over here on the one side. Now it's probably a little small for some of you, but that's in the pond level in feet. And then the blue line is the rainfall. So what they're looking for here is trying to establish a relationship between the rainfall events and how much the pond level went up. And they found that you could get up to a 7 times multiplier effect, because the pond is collecting water from the watershed around the pond. So, for a 1 inch of rainfall, you could get a 7-inch increase in the pond level. So they had to kind of plan for that as part of their emergency action plan. And this is just kind of an excerpt from their emergency action plan. And it's probably a little small for some of you to see the details if you're looking at this on your phone or something, but let me just kind of hit the highlights of this and walk you through it. Over here on the left is a side view of their dam, which has this AgriDrain device in it, which is controlling the water level, and has an inlet and an outlet. The outlet goes to a downstream drain that they use to drain off the excess pond level. And it also has a spillway that usually is not in effect, but this is, as it gets into a storm event, that'll spill some of the water. And over here, it's just looking at the different responses based on the rainfall forecast versus the current water level. So, and they've done some clever things here to help with communicating their emergency action plan in terms of, red is for more extreme events that they're anticipating. Yellow is for, just, still something that they need to take action with, but maybe not quite as extreme. And then below that is no action required. So based on the current pond levels, as well as the anticipated rainfall, they remove a different number of plates. So in this case, they're probably going to be okay. They don't have to remove any plates within their AgriDrain control. In these events, they're expecting more rain, so they need to drain off more of the pond level in anticipation of the storm event. So they remove more of the plates in their AgriDrain. So this is so that they've lowered the pond sufficiently so that it can handle the expected rainfall. So you guys, of course, your situations will all vary, but I thought this was a pretty good way of looking at it. So maybe you can get some ideas from this. And of course, they had other parts of their action plan as well. Some of the things that they learned in this deployment was they mounted the station on a pole in their pond, so it avoids casual vandalism. I saw some questions in anticipation of this, and even during the webinar, asking about how to avoid vandalism. So this is one thing that helps with that. The Weather Underground, they found, is a good source for rainfall forecasts because it provides anticipated rainfall in inches per hour, and it can tell you when that's going to be coming. So, so that's a useful tool you may want to include as part of your EAP. They like the fact that you can have a dashboard view that can be shared with association members and safety officials, with different dashboards tailored for each of their needs. And they also, of course, is very common is the ability to get alarm notifications if water levels get too high or too low, or if the rainfall is exceptionally high. They need to know that as well. So those are some of the things that they learned. So I do want to take a moment to thank Howard Goldberg, who shared these images and analysis with me and his insights. So he was great. So thank you, Howard. The next example I have is a statewide dam monitoring network. And in this case, we don't actually have approval to share their name, but it's certainly fine for us to talk about their application and just some of the things that they incorporated as part of their network. In this case, they're managing over 100 dams, so a big statewide network. And with that large a network, it's certainly not possible to be checking and monitoring water levels manually. So you really do need a comprehensive system to be able to keep track of those. And they, of course, need notifications, immediate notifications, so that they can take action. So those notifications go to the managers, who take appropriate actions and responses as necessary. And in this case, they integrated some micro RX water level stations. Again, they like the fact that it's the non-vented water level sensor, which reduces the amount of maintenance that's needed. They use the rainfall sensors as part of that. Most cases, users will be using both the water level and rainfall sensors, we're finding. And they use the alarm notifications. They like the fact that it was easy to deploy. And in this case, they were integrating it into it's a product. The commercial company is the commercial product is DamWatch. It's a joint venture with the NRCS, and it's used in many states around the country as a dam and water management tool. It provides notifications to dam managers. It's got a lot of other tools integrated into the platform for dam management, such as places to file EAPs, integration with other data sources. It's so of course it was important for them to be able to integrate into this network. So HOBOlink, as I mentioned, has the web services, and I think they use data delivery in this case to get the data to into their platform. So so that's the two examples I wanted to go through real quickly. So I got about 3 minutes for questions. So what I'm going to do is start taking some of your questions, and because of the network problems, I'm going to leave my camera off. And I'm also going to, in case any of you have to go, I'm going to advance one slide, which just has our contact information, where you can get more information either by contacting us, one of our application specialists, as well as our website, which is a wealth of information, like webinars like this one are stored there, applications information, tutorials, all sorts of self-guided tours. So with that, I'm going to go back to questions. Here's a question on, in areas where vandalism risk is high, would placing the RX unit in a chain link enclosure interfere with the operation of the unit, solar panels and data transfer functions? So this comes from Richard. So good question. And that is a pretty common approach that's used, is to put it in a fenced off area to protect it from the station from vandalism. And yeah, the communications, the cellular communications, no problem going through the chain link fence. You can, the solar, yeah, usually no problem. We've got enough margin in our solar panels to cover those, to provide plenty of power. If you needed to, our micro station does have the option to connect an external solar panel, so you could do that. So you can mount that external solar panel higher up. In some cases, people even will mount our micro RX station inside another enclosure. So it has to be a plastic enclosure in that case, so that the cellular signal can go through the enclosure. But that's another way of providing additional security around the station. Oh, here's a lot of questions on this. I just see a question here from James. Can the RX 3000 go in an underground vault? And that could be problematic, because if it's got to be something that allows the cellular signal to go through it. So a lot of the underground vaults will block the cellular signal, and we don't have a good way to connect to an external antenna. So you really do need to be able to mount either the RX 3000 or the micro RX in a place that has cellular connectivity. I see, yeah, there's a couple follow-up questions. I think we'll have some of our application specialists follow up with you. Oh, here's a question. Let me address this real quick. How do you know if you have enough cell signal to operate reliably? The best way to do it is take a cell phone out to the site that uses either AT&T or T-Mobile as your, ideally you have one of each to check the connectivity through that and see if you can get cellular connectivity to that cell phone. But yeah, that's a common way of checking for enough signal strength. So yeah. So at this point, I think I have hit my 1 hour mark. So I'm going to sign off. We will review the questions after the fact, and any questions that weren't covered during the webinar, we will follow up with you personally. And as I said, at any time, feel free to contact us. We're happy to help answer any questions you have. And finally, I just want to say thanks to all of you for attending. It's been a pleasure having a chance to talk with you today. As you go, make sure to share your feedback with us. We're looking to continually make our webinars better, so we appreciate your feedback. And as part of that, also let us know if you'd like us to follow up with any specific questions on your application. So thank you, everyone. I wish you a great day.